Hello guys and welcome back. So now I have this wall here from the main building and we're going to take a look at the new nodes in Houdini 17. The first one is called RBD fracture. There's a new drop down in here and I'm going to create the RBD material fracture. It takes a few seconds for it to create the node the first time, actually every time you drop it, and let's view it. You can see it's fracturing the geometry now and displaying the result to us. Now the geo is not that high res, but I'm gonna keep it like this for now. And the main, if you look at the UI, it's completely different. And what this node is it's an OTL or an HDA that side effects build on utilizing all the features from Houdini 16.5, the Boolean, the Voronoi fracture. And also the attempt with this workflow is to simplify the process that needs to create a fracture the geometry and prepare the constraint. And as you can see, it has 4 inputs, which we're going to talk about later, and also 3 outputs that we'll cover in a bit. But the main feature, the main advantage of this node is that we can get some interesting fracturing pattern. As you can see already, it's pretty unique. There's a lot of It's random. There's no repetition or anything like that, similar to how it would look if we were using Voronoi. And the cool thing is it has this fracturing level option. So I'm going to turn off the second tab here, and this is the way it works is it does layered fracturing, which is something I've been doing for quite some time. So you fracture the geometry once and then you loop over each one of them and fracture it again, and then you do another. It's a recursive loop, and you can add level as many level as you want with this. So I'm going to hit the plus button. It's going to add a third tab. Okay, it's off. Let's turn this off. And we can add as many levels as we want. So the first one is doing this fracturing, and then I'm gonna enable the second one. In the higher the scatter points, the more it's gonna fracture these pieces. Now you see here is the fracture ratio, is how many pieces it's going to affect. The first level, let me turn this off. The first level had 5 pieces, 1, 2, 3, 4, 5, and if we use 50% of that, the ratio of 0.5, it's only going to affect 50% of the pieces. So the chance of this fracture level happening is based off of this ratio. Okay, and this is the scatter point. Typically, we do, when we want to fracture geometry, we do a VDB from polygon, convert it into a fog, and then scatter some points. Yeah, that's the volume, and then scatter points on this volume. Now to break this, these points, we tend to distort this volume or randomize it, and that's what's built in by default in here. You can see there is a fog volume, which is basically a volume representation of the mesh. We can add noise to it, and this will help randomize the distribution of the points. And this is the scatter control, which is basically this. And so if we wanted to increase the number of pieces on the second level, we just increase this number here, and I'm going to do that. I'm going to do that in a second. So I'm going to set this to 15, and it's going to take each piece and fracture it into 15 smaller blocks. We can do this. We can go another level and fracture each of these guys one more time. So this will be fractured 5 times, and this will be fractured 5 times, and so on and so forth. And this is basically how this node works. And honestly, I'm still not sure why it's not uniformly distributing this. I would assume the noise here that's been the noise that we're using is the volume fog is very different between each section. That's why we're getting some points here, but not so much in this area. And what I'm going to do is I'm going to disable the update because it's a bit slow. I'm going to lower the So I'm going to increase the resolution for the volume, and I'm going to reduce this. And noise frequency, there's no noise amplitude. Yeah, so let's lower this and lower this. And I'm going to lower the noise as well so it doesn't repeat that much. I'm also going to increase the resolution here, and let's turn this back on because the object is quite thin. And it's cooking, as you can see here. It's going through. Cool. Yeah, so it's not perfect, but it's working. So what I'm going to do is I'm going to reduce the resolution of the mesh because it's a bit slow. I want to cover one more feature. Let's set it 10%. Okay, and then let's take a look. Here it should be faster to process this mesh. It's still reasonably slow for this resolution, I think. So I'm gonna disable these two levels. Okay, and let's go back so it's fast now, and then we're going to talk about the detail feature. So if we turn on edge detail, it's going to break these edges, and this is really cool because it's basically something we always need when it comes to destruction. So we can increase the resolution of the height of the edges. And the reason why this is working is because it's using the boolean under the hood. Okay, and we can lower the scale, something like this. Cool. And we can increase the detail size of the interior faces. So this guy here is for the interior details, and we can also add noise to that as well if we wanted to. So this node allows us to get high-res meshes right away. The cool thing is with these three options, we're gonna get something really useful. If we take a look at the first one, this is our high-res mesh that we will use for rendering. Okay, then the second one, the second one is an actual constraint network, and this is given to us by default now. So there's a constraint network that we can use for destruction right away, and this is the coolest feature. So you can see here we have a version that doesn't have the edge displacement, and this is ideal because this is what we want to use for the sim, for our sim, and then we swap them and use this for rendering. So we sim with a low res version and use this for rendering. Now all these features are something that we can build without using the RBD or material fracture. There's nothing new in Houdini itself. It's just this node allows us to do that, but we can always build this from scratch if we wanted to. There's nothing preventing us from doing this. Now the main issue that I have with this node is speed. So let me turn this on. Okay, so we have that, and let's enable this. and it's cooking right now. Okay, so the generation is done, but remember, this is not the high-res mesh. Okay, I'm actually going to turn off the increase this. I think it's quite high. And this is not the high-res mesh. This is 10% lighter version, and this is one piece. And the intent, the other main feature for this workflow is to use it in conjunction with other nodes. So let me go back. Let's disable this and see how much it's going to take to cook this node, to fracture this piece of geometry using this node. Now this node, this workflow, the RBD material fracture, is intended to be used in conjunction with, or chained together. So you would have a node RBD fracture, material fracture for concrete, and then another one for glass, and another one for wood, and you would chain them together, and it will provide you networks networks between all these materials. So you can say, okay, this is the network, the constraint network that connects the wood to the concrete. This is the one that connects a metal, glass to wood, for example. And so we're gonna see that feature as well. But as you can see, it's a bit slow for this. Now, the other thing that I personally don't like is that if we change this, it's not gonna go and only update fracture level number 3. It's gonna redo the whole thing. So interactivity is a bit of an issue here. If we have our system that takes 10 minutes and then we want to change level 5 of fracturing and increase that or lower that, it's going to have to recook the whole thing multiple times, which is a waste of time. So we want something that is better than this, much faster than this. And so this is not, we're gonna leave that for later. And in the next video, I'm going to talk about the constraint and how this works with other materials, and how Side Effects designed it. We are not going to be using this in the workshop. We're going to create something that is much faster and more efficient in my opinion. If I'd really encourage you guys to continue to explore this. If you like this workflow, if you like the result, definitely use it. There's nothing that I personally think prevents you from using it. I can build something faster, so I'm gonna do that. And this feature here, the interactivity for these level is a big deal for me, because I want to be able to quickly do the recursive thing and iterate over the mesh as I need to. Now, the other thing that a main feature of my workflow is I need to be able to create multi-level constraint network for each fracture. And this is something that is not built in. So let me disable this. And I will explain why I want this feature to be available, or actually not having it is a limitation. So I want to be able to say, okay, I want a constraint network for this level. Give me that. I want a second constraint for the second fracturing. So it will group, if I take this piece and fracture it into 5, it will give me a constraint network for just those guys. Okay, and then I want a constraint network. Let's say I take this piece, for example, a third level, and I fracture it in 3. I want to have a constraint network for that. So this way I can control or easily do a multi-fracturing setup in DOPS if I wanted to. And this is very, very useful for creating things like crumbling, or a rock or a cliff getting sliced and crumbling and falling down and things like that. So this feature is actually very important, I think, and we should have access to that. So we'll continue We'll continue understanding this workflow, and then next week we're going to start building something of our own. Thank you guys for watching, and see you in a bit.